Okay, today we are working on Unit 5, Lesson 8, which is position, speed, and direction. We're going to use signed numbers to represent movement. For our warm-up, an airplane moves at a constant speed of 120 miles per hour for 3 hours. How far does it go? So we can take that speed of 120 and we can multiply by the 3 hours, which will give us 360 miles. In our second example, we have a train moving at a constant speed and travels 6 miles in 4 minutes. What is its speed in miles per minute? I'm going to go ahead to my next slide and I'm going to put in my information in this little table because that's kind of what we've been doing. And it goes 4 minutes and it goes a distance of 6 miles. And we want to figure out how fast it goes in 1 minute or how far it travels in 1 minute. So we need to divide by 4. We can divide our 6 by 4 as well, and that will give us 1.5 miles per minute or 1.5 miles per minute. Okay, I'm just going to erase this, and then we'll go back to that other question on the previous, for me on the previous slide. For you in your book, it is all in the same spot. Okay. Last one, a car moves at a constant speed of 50 miles per hour. How long does it take the car to go 200 miles? Again, I'm going to use my table that I have over here. And we have a distance of 50, and it goes 50 miles in 1 hour. We want to know how long does it take it to go 200 miles. So we got to figure out, what do we multiply by here to get to 200? We're going to multiply by 4. So on the other side, we're also going to multiply by 4. 1 times 4 is going to give us 4 hours. So in order to travel 200 miles, it's going to take us 4 hours. Okay, it looks like I need to erase what I put on there. Our next activity, we are going left and going right. Activity 8.2. So we have a number line here, and you're going to be given some directions on which way to move. After each move, record your location in the table, then write an expression to represent the ending position that uses the starting position, the speed, and the time. The first row is done for you. I'm actually going to go over here into this PowerPoint that I created, and let's see if we can, not share, if we can present that. All right, so let's see. I'm not sure that it's going to let me write on here. I think it only gives me a pointer to use, but we'll try this. So if we start at 0 and we move to the right, and we are going to move 5 units per second. So we're going to go for 3 seconds. So therefore, we're going to go 5, that's 1 second. 10, that's 2 seconds. And then we'll end up at 15, that's 3 seconds. Whoops. Right, so we have 5 is our speed, 3 is our time. Our ending position will be at 15 units. And the expression that you can write for that is 0 plus 5 times 3. Go ahead and pause the video for a minute and see if you might be able to figure out the next one. I'll go through it with you real quick and then you can pause it. But you're going to start at 0, and now it tells you to move to the left. So you'll notice when we move to the left, we're going to be working with negative numbers. So if we start at the 0 and we go 4 units 6 times for the 6 seconds, where do we end up? And if you do that, you'll notice that you end up at negative 24. So your ending position is going to be negative 24, and your expression that you're going to write there is going to be 0 minus. All right, let me go ahead and put you guys to the next slide. Pause the video for a minute, see if you can fill in the chart on your own, and then check your answers with the next slide. Okay, here's our next slide, and as you can see, we have that ending position of negative 24. We start out at 0. We take away the 4 because that is how many units per second we move. That's our speed. Multiply that by how many seconds we move, and that gives us our final position of negative 24. Go ahead and check your answers with these. And we are going to move back in to the lesson and move on. Okay. So the question that comes up next is, how can you see the direction of movement in the expression? And you can see that the direction of movement is represented by whether you add or subtract from 0, whether or not you're going to the right, which is a positive, or going to the left, which is a negative. And then what they ask you to do is to write an expression using these variables. Now, we haven't done a whole lot of work with variables yet this year, so I'm just going to write it down for you, and don't worry about the fact if it's a little confusing. I think as you move through it, it'll make more sense. If you're moving to the right, we're going to be positive. So we're going to put in a P, and that P represents your starting position right there. Okay. So we're going to add, because we're moving to the right, we're going to add the speed. And that one we were talking about right here. There's your speed. So I'll go ahead and make that blue. And we need to multiply. So when we multiply, we're using that dot now instead of the X, because we're working with variables. And when you have variables, you don't want to put an X in for multiplication. That gets it a little bit confusing. And then finally, we are going to take into consideration time. And so we're going to multiply by the time. So we have the starting position plus our speed multiplied by the time. Okay, the second equation that you can write has to do with moving to the left. This equation is very similar. We have a starting position, but this time we are going to subtract. Because we're moving to the left, we are going to subtract our speed, and then we are going to multiply our time. All right, these are just a couple ways of representing our movement with an equation. All righty, let's move on to the next slide. Oh, and it looks like I'm supposed to erase again. We're going to move on here to activity 8.3, which is called velocity. All right, we're going to explore a real-world situation, and we're going to be multiplying positive and negative numbers. And that's really what we're working on here. We are trying to get you guys moving into multiplication of integers. All right, so for this one, it's very similar. We have a traffic safety engineer that's studying travel patterns along a highway. She set up a camera and recorded the speed and direction of cars and trucks that passed by the camera. Positions to the east of the camera are positive. Positions to the west are negative. And we're kind of going to have this assumption that we just start at 0. Vehicles that are traveling towards the east have a positive. So you'll notice this positive right here. East is going to be positive, that's to the right. And left is going to be negative to the west. And that's how we're going to determine which direction they're going. All right. Complete the table with the position of each vehicle if the vehicle is traveling at a constant speed for the indicated time period, and then write an equation. This is very similar to what you just did. The main difference is that we are just going to assume that we have a starting position of 0. So in front of these, you could put a 0 for the starting position if you're thinking about that formula we were working on, because each time you're going to start at 0. Then you're going to either move to the right or the left, to east or west. In this first case, you're going to go 25 meters per second to the right, traveling to the east. The time that passes is 10 seconds. Positive 10 seconds. And so if we use the formula that we were using before, the equation, it works again. We start out with our velocity, our speed of 25. We multiply times the time, the elapsed amount of time, which is 10 seconds. And that gives us an ending position of 250 meters to the right, to the east. In the next situation, we are going to start at 0, and we are actually going to travel to the left. We're now going to move at a velocity of negative 20 meters per second because we're moving to the left, to the west. We're going to do that for 30 seconds. And so our ending position is actually going to be negative 600. This negative representing the fact that we have moved to the left, that we have moved west. And so to write a formula or an equation for this, not a formula, but to write an equation is going to be a negative 20 times 30 will equal negative 600. All right. So what I'd like you to do is go and see if you can figure out how to finish the rest of this table. Pause the video, do your work, and then come back to the video and I will display the answers for you. All right. So here are the answers for that last activity that you just did. Go ahead and check your answers, pause the video, and then we will move on to the end of our lesson. Almost done. All right. Let me go ahead and erase that. All right, if a car is traveling east when it passes the camera, will its position be positive or negative 60 seconds after it passes the camera? It will be positive because we're going to the east, to the right, so it'll be positive. And basically what we're getting to with this activity is to understand that if we multiply two positive numbers, is the result going to be positive or negative? It's going to be positive. If a car is traveling west when it passes the camera, will its position be positive or negative 60 seconds after it passes? It will be negative. That is because if we multiply a positive with a negative number, our result is going to be negative. You may want to write these two down. That's something to keep in mind. Positive times a positive is a positive. Positive times a negative is going to result in negative. All right, so hopefully after going through this activity, I'm just going to come here to the end. You will find that you can multiply a positive number with a negative number and you will get a negative number. You can use rational numbers to represent speed and direction, and that's what we were doing with our traffic safety engineer and also with the train. All right, please make sure you check on Schoology to see what your assignment is for today.